Nerves of the abdominal wall. Basically, we're going to look at the spinal nerves as they're coming and distributed over the abdominal wall. Uh, the one which comes right behind the last thoracic vertebra, which runs caudally there, that is your costo-abdominal. The one before that is coming behind the 12th thoracic vertebra, 12th rib and 12th thoracic vertebra, so that is your T12. The one which is T13 is called costo-abdominal. Then we have a nerve coming behind or coming after the L1, which is called cranial iliohypogastric. Though part of that is missing here, further continuation can be seen as your cranial iliohypogastric. Then the one which comes after L2, that is your caudal iliohypogastric, and then the one which comes after L3, that is called ilioinguinal. So this is going to go further down into the inguinal region. All of the nerves on the abdominal wall, though they are located on the transversus abdominis muscle, they're going to give off lateral branches which comes through the muscles, and they also take care of the superficial aspect of the abdominal wall. Okay, so let's review those again. So we have one coming after T12. Make sure like this is not T13, this is T12. This is T13, which is costo-abdominal. Then L1, which is cranial iliohypogastric, L2, which is caudal iliohypogastric, and L3 is your ilioinguinal. Now the fourth one, which is L4, which is called lateral cutaneous femoral, is basically seen distributed over the cranial and lateral aspect of the thigh. So here we're looking at the parietal surface of the liver, where the diaphragm is going to make contact with the parietal surface. As we take the diaphragm away, we expose the parietal surface of the liver, and the other side we have the visceral surface of the liver, where the major organ which makes contact is the stomach, and so it's going to leave some concavity, which is impression of the stomach on the parietal on the visceral surface. Also, the right kidney is in very close association with the liver, so right kidney makes contact with the liver, specifically with the caudate process of the caudate lobe, but majorly the caudate process of the caudate lobe is going to have that big impression, that is your renal impression. Now it can be used as one of the landmarks. So we can see the kidneys, or the right kidney makes contact with the caudate process of the caudate lobe, so that is always on the right. Okay, so let's look at the lobes of the liver and some of the features that we see on the ventral border. So starting from the left side, we have the left lateral lobe of the liver, from the visceral surface, from the parietal surface. Then as we go more medially, we have the left medial lobe of the liver. Then there is a notch or groove between that one, so that is called notch for the round ligament. And round ligament, as long as it is present, it's going to be in between the left medial lobe and the quadrate lobe of the liver. So the one which is right here is called quadrate lobe, because it further can be divided or four smaller divisions, but we don't really see it all the time. Okay, so those are that is the quadrate lobe, and then from the quadrate lobe we see some space here, that is space for the gallbladder. From the visceral surface, we can easily separate the quadrate lobe from the right medial lobe, and so that is the usual location for the gallbladder. As long as the gallbladder is present in that particular animal, the gallbladder is going to be present between the quadrate lobe and the right medial lobe. It depends on, in some other animals, the lobes may not be further divided as lateral and medial, but then the gallbladder would be always between the right lobe and the quadrate lobe, while the round ligament would always be present between the left lobe and the quadrate lobe. Okay, so let's move further to the right side. So that is your right medial lobe, and that is the right lateral lobe. The right lateral lobe is usually accompanied by a process which extends from the caudate lobe. The caudate lobe in this view is a little bit difficult to see, but if we go all the way to the dorsal aspect of the liver from the visceral surface, that part of the liver which is dorsal to the hilus of the liver can be called caudate lobe of the liver. From the caudate lobe, we have two important extensions. One on the right side towards the right kidney is the caudate process of the caudate lobe, and one which comes or which is extended further on the left side, which sits along the lesser curvature of the stomach, is called papillary process of the caudate lobe of the liver. At this point, the papillary process is still covered by the lesser omentum. As we just push the lesser omentum aside, we can see the papillary process which would fit into the lesser curvature of the stomach. So this is papillary process of the caudate lobe of the liver, and that is your caudate process of the caudate lobe of the liver. The caudate process is closely associated with the right lateral lobe. The papillary process is closely associated with the lesser curvature of the stomach. Okay. Now let's look at the ligaments of the liver. So first of all, we'll look at the ligament which is called coronary ligament. The coronary ligament is simply attachment between the diaphragm and the liver. Wherever diaphragm is attached to the liver, it's going to be attached by means of reflection of the parietal peritoneum into the visceral peritoneum, and that's how that connection would be established between the diaphragm and the liver, and that structure is called coronary ligament. So the coronary ligament would usually extend from the left triangular ligament that we can see right here. That small part where the diaphragm is attached to the left lobe of the liver, that is the left triangular ligament. Continuing from the left triangular ligament, we see the coronary ligament, and as we follow the coronary ligament all the way to the right side, we're going to come across the right triangular ligament, which is also present between the liver and the diaphragm. Okay. Again, in this specimen, it's like much smaller here. So that is your right triangular ligament. Between the right triangular and left triangular, we have the coronary ligament. Now let's look at the falciform ligament. The falciform ligament in most of the adult dogs can only be seen as remnant, and along the free edge of the falciform ligament, sometimes we might be able to see the round ligament of the liver as well. But usually it should sit in between the left medial lobe and the quadrate lobe. The falciform ligament is the membrane which runs between the round ligament of the liver and the body wall as well as the diaphragm. And so that membranous part which accumulates a lot of fat after birth, that is the falciform ligament. So how far falciform ligament would extend in the caudal aspect of the abdominal cavity? It will extend up to the umbilicus. From there backward, there is another ligament which is present here, that is present along the ventral side of the urinary bladder. So that is the median ligament of the urinary bladder. Okay. So both of them are actually attached to the umbilicus because both of those structures are remnants of some fetal structures which were necessary in the fetal stages. The round ligament is remnant of the umbilical vein, and the median ligament is the mesentery of the structure which is called urachus, which actually is responsible for draining the waste or urine from the fetus, which is from the bladder to the one of the fetal membranes, okay, or to the cavities of the or fluids which surround the fetus. Okay, so that is the umbilicus right here, which can be palpated from outside as well. From that point, we can see cranial to the umbilicus we have the falciform ligament, caudal to the umbilicus we have the median ligament of the urinary bladder. Okay. The falciform ligament. As we see in this specimen, the falciform ligament is intact in the region of diaphragm as well as in the region of the abdominal wall. Usually, the round ligament is present on the free margin of the falciform ligament, which goes between the left medial lobe of the liver and the quadrate lobe of the liver. The notch or the groove here is called notch for the round ligament, and so we have the round ligament and falciform ligament which is associated with that, running between the left lateral lobe and the left medial lobe and the quadrate lobe. The falciform ligament on its other side is attached to the diaphragm as well as it is attached to the floor of the abdominal cavity. In most of the other specimen, what we observe that this part of the falciform ligament is missing because as it is broken in the adult life, it usually gets regressed, and so we may not necessarily see that part of the falciform ligament present in most of the other specimen. Okay, what we usually see is the caudal part of the falciform ligament remains, as there is a lot of fat deposition occurs along with that. Okay, so that is your falciform ligament. The round ligament is not so prominent because it is completely regressed, but it should be present on the free edge of the falciform ligament. Okay, so what you see here, that is the gallbladder right here, and the duct which extends from the gallbladder towards the small intestine, that is your common bile duct. Okay. Right here we have the common bile duct extending from here all the way to the small intestine, or specifically the duodenum. Then look at these ducts here. So that's your hepatic duct. That is another hepatic duct coming into. All of them supposed to come into this one and further go towards the gallbladder. So the duct which is present right here, which receives all the hepatic ducts and continue towards the gallbladder, is your cystic duct. Okay? So the cystic duct is the duct which is going, or which is associated with the gallbladder, which would receive all the hepatic ducts. But then from the place where it does not receive the hepatic ducts, and then it goes further towards the small intestine to open through the major duodenal papilla, that is going to be your common bile duct. So